Welcome guys. In this NXCAM tutorial, we will cover milling and turning example. So in this tutorial, we will take you through the process of creating a multiple spindle mill-turn program. So there will be a main spindle and a sub-spindle. We will define the setup, create turning, milling and drilling operations and manage the in-process workpiece as it passes from one spindle to the other. So the workflow consists of three parts, right? The first one is setup. How you set up the part for the main spindle. We need to include the stock which is a blank. It could be from casting, forging or a bar stock. Then we need to define the part. We need to define the program and we need to define the output. So once you have the model file into the layout, the next thing you need to do is go to File, New. So once you hit the file and new, you will have a window pop up. This is the window you see on the screen. So new, you're gonna cursor over to manufacturing tab. Okay, so pick this tab, manufacturing tab. You'll have a different options: general setup, die mold, turning, machinery, multi-axis, mill-turn, simulation. Now you're gonna click the mill-turn. All right, so once you have the part in there, analyze the part for setup, for programming, output. Then what kind of template you need? You need a mill-turn template. The reason being is the part that you have features that need a drilling, milling, turning in all to complete the complete part. So now what you do is select this, then hit OK. It's important, guys, understand the units for the part given. It could be in metric, it could be in inches, standard. So analyze the part, use the one of the menu option here to go and pull the analyze ribbon bar, go and find out the diameter, go and find the length, then you select the units accordingly. So once you go and pick the manufacturing tab, MILLTURN Express, this is the window you will get, right? This is one of the part given in Siemens to give you how to go through the MILLTURN Express, right? So now you got the part, you got the turning, milling that need to be done. Now go back to the left hand side, hit the right hand hit the right mouse button, do the expand all. Once you expand all, you see different icons already set up for you. Again, you want to go and put a new object. It's such an easy thing. I covered in a lot of tutorials before. You can look at the tutorials, the old ones, or I will tell you how to create it. Just click the main one, the parent object, go to create geometry. You can create any type of geometry you want. If you have MILLTURN Express, that's your template. What do you need? MCS, main spindle, you need a workpiece, you need a turning workpiece, right? So all these things, your containment boundary, all those things are given for you. You can pick whatever you want. You pick and choose, you will drop below that. So now you're gonna set up this setup right here defines a hierarchy of geometry groups that will allow you to specify the geometry and the parameters that are commonly used throughout the program, right? Once you set up the template right, guys, you'll never have a problem down the line, right? So do the setup right, fundamental foundation, set it right. The organization of the machine coordinate system, the MCS, which will contain the turning, milling and hole making operations, is really important. How do you set it up, right? So the data MCS is the MCS, machine coordinate system. That's the parent object. Every one of the child object will be underneath it. So you can see it. This is the MCS. Below that, workpiece main spindle turning, avoidance geometry, MCS mill. This for the milling operations all done in the main spindle. The hole making operations all comes under the MCS. They will be going into done in the main spindle. The turning workpiece in the main spindle. Now for the MCS sub spindle, your Z will be 180 opposite of what you have the Z in the MCS. Now you do the same thing. So now let's go back at the machine tool view. Do the expand all. How many stations are defined already? We got 1, 2. Station 1 got a 180 tool, right? All right. So now what you got in the 55? It's defined for you. So basically the left hand side, you're seeing the turret, right? It's simulating a turret with several stations. Common turning tools have been already defined by the setup itself. Once you go, like I told you, once you go to the manufacturing tab and pick up the MILLTURN Express, I will put in all the models that you needed to simulate the toolpath along with the tutorials in the link given in the tutorial. The establish the framework is being done now. So you want to change it, change the clearance angle, change the geometry of the tool. Go and do the right click, edit. Pull it out and see what you got. Okay, is that what you want? Nose radius, orient angle. It's all to your liking. Tracking was the tip of the program code output, CNC code output is going to be output at the right at the tip of the tool. So if you want to do it to center of the tool, nose radius programming, it's different. You can, if you want, you can change it. There's most of the common tools out there. That's what it's programmed to the tool tip. Okay, cancel it. So now what we're going to do is we're going to define the geometry in this task. So you'll create a sub-spindle assembly that will define the MCS, define the part, blank geometry on the main spindle, and also the define the part and blank geometry on the sub-spindle. So whenever I do the right click fit, so what you're going to do is now choose the. Okay, now we need to add a path to define the sub-spindle child objects. So everything will be go underneath the sub-spindle. So what we need to do is we need to add one more iteration of the same component. So go to add, the assembly tab, go to add. So pull the same part one more time. Go into how do you want to add it into the current part, right? So go to move, hit OK. So what you want to do is you need the sub-spindle part to stay away 100 millimeter from the main part. So now you got the sub-spindle part to put in the sub-spindle define. So your sub-spindle in your machine tool is more than 100 millimeters away from the main face of the main spindle, right? You can move it as per you want. You can be 300 millimeter, you can be 500 millimeter, or you can be 150 millimeter. So find out how it's the length between the main and sub-spindle. Hit OK. So now it's time to define the sub-spindle part, right? So now just go back and see how you want the orientation all defined, right? Is that right? So all things are done on the main spindle. Sub will be taken this way. That sounds right. Okay. Now you go. Let's go back and go to the geometry tab. So let's go and specify what I would need to do to define the MCS and sub. So now we got the sub-spindle part pulled into the layout. Now it's time to put the part, define the part into the sub-spindle for the MCS. That's right here. Okay, right click, edit. Okay, where do you want the MCS, machine coordinate system, for your sub-spindle? Sometimes people do that. The front face of the part as the datum coordinate system for the sub-spindle. Somebody will put it in the chuck where the part will be located on. So if there is a chuck right here, so right here they will put it in. You will select the back face of the part on the main spindle. Okay, so that means like when we go and clean up the face, we need to know how much we're going to take off. Let's select the plane, specify this is the Z and X axis. Make sure that this is what you selected. This is what the tool path will be created upon. Z and X plane. Okay, now we're going to put the MCS right here too, from here, right? So go back and select entire assembly, what you need. Your MCS to be right. So now that's Now it's time to set up the stock. Hit right mouse button in the background, select the view, what view you want however you want, the whatever is comfortable to you, select it. For me, it's always good to be in the top view. Now it's time to set up the stock. So there's like a n number of ways to set up the define the stock for the main spindle. So now if you want to do it in the master blank, either you can define the geometry as a solid geometry in the modeling, and you can select it as a stock, or you can select it over here. If you got to go do this as a bounding cylinder, but you need to know that we'll be giving a stock of 1 millimeter for the front files cleanup. Current blank settings. Okay, we need to select the part geometry. Now let's see how to select a blank here. You can do the two. So we need to, for the transfer, because we need to have a stock in the main spindle, while the cutoff tool comes and cuts a clean cut, transfer to the sub spindle. So we may have to change the number to right. How much stock you need? Not more than that. Okay. What you need? Okay, that's about 2 millimeter. Right, that's good enough. So like I told you guys, you can define the blank in different types. So you can do it as a solid geometry, or you can do it in the master blank, workpiece. We do it in the workpiece. So now it's time to set it up MCS, sub-spindle, work part, and the transfer. The critical thing that you need to watch up here is how do you transfer the part. What are the part operations are done on the main spindle? We need to transfer the in-process workpiece to the sub-spindle. So that way, the remaining tool path is applied only to the workpiece that been partially completed in the main spindle. Blank boundaries, we need to define the blank, right? So select the workspace. So if it's a standalone operation, you can select the bar stock, tube stock, whatever the blank you're working with. Since it's going to be a in-process workpiece transfer, that's partial operations are completed in the main spindle, we need to select the IPW, which is in-process workpiece. You need to select the workspace. Now you need to specify the reference point. It has to be always the IPW is in reference to something else, right? Where is the reference coming from? You need to select the point dialog. So remember that we know that from here we put our sub-spindle right on the 100 millimeter away from the face of the MCS, main MCS. So what is that? Minus 100. Do you remember that? So if you not plus refresh it and look at it when we define the sub-spindle, where we put the sub-spindle with respect to the main spindle stock. Okay, 100 offset none. So that's the reference relative to when you define the workspace, it's always a reference and target. Okay, now we define the reference, now we specify the target. The target is right on the 0 point. So now we need to infer the point, which is right here. So if we define both, select OK, the blank is defined.